Excellent. Then the next thing I want to discuss in Unit 3, where we're discussing I/O management, is to actually take an examination of the basics of streams. So we saw in the overview that the I/O class has a multitude of concrete classes that implement input stream and output stream. So let's focus in on just defining what a stream is. So quick overview for this particular presentation is we'll do an introduction to streams, and then we'll talk about the different types of streams in Java, and then we'll focus in on input streams, and then we'll move to output streams, and then we'll talk about streams in Java in general. Then we'll talk about the system streams, the default built-in streams, and then we'll just take a quick look at the steps that we would normally take to read data from a source into our Java program, and the step-by-step process we'd want to do to write data from to a destination from our Java application. So a quick introduction here is that a stream in Java represents a sequential flow or an unbroken flow of data from one place to another place. So in other words, a stream is a path along which data flows, like a pipe along which water flows. So it's required to accept data as input from the keyboard, and the data in the form of a stream may be bytes or characters or objects or whatever, right? Like if we're serializing, then we might be sending our objects from one application to another application across a network. Or if it's a text file, we might be parsing our stream in the form of characters. Or if it's, say, a class file or Java file, it might be in the form of bytes. So let's try to understand streams with a real world example. So you can think of a river as a stream of water that flows from one place to another, right? So a source to a destination in a continuous sequence. So a source and destination are connected through that continuous flow of water. And so very similarly to the way that a stream works in the real world, we can think of data being carried from one place to another across applications. So in Java I/O, our data flows from a source known as a data source to a destination known as a data sink, as shown in this below figure. The data source and the data sink are connected through a Java program. So here I'd have my source, and then we'd have an input stream. So our Java app would use an input stream from the data source to be able to get data into it, and it would set up an output stream to be able to send data out to a data sink or a destination. And so our Java I/O program reads data from the input stream, writes data to the output stream. So a stream is always required if we want to move data from a data source to a data sink. For example, a stream can carry data from your keyboard to memory, from your memory to the printer, from the memory to a text file. So types of streams in Java, basically there are two types of streams, as you might predict, input streams and output streams. So for input streams, we're going to look at the top of this figure here, where we're reading data from the data source into a Java program. A stream that receives or reads data from a data source and sends it to a Java program is called the input stream. And so input represents the flow of data into a program. The input stream connects the data source and a Java application, as seen here in figure A. And as you can see, the data is read from the data source, and the flow is sequential into the Java application. And then for an output stream, well, a stream that takes data from the Java program and sends or writes the data to a destination, or what we call a data sink, is called the output stream. And so an output represents the flow of data out of our program. And so the output stream connects the Java program and to the data sink so it can write that data. And again, the output stream is represented in the B here, where from our Java program, we write to the output stream that sends that data into the data sink. Whereas on our data source here on our input stream, we would read from the input stream to be able to access that data inside of our Java application. So just some words about streams in Java. Just a quick note that Java represents all streams by classes that are defined in the java.io. So that's our input and output package. This package contains a lot of classes, all of which are divided into two basic categories, input streams and output streams. So let's talk about the system streams, because when you were in 1583, now we're now expanding the concept of how input and output works, but you did input and output in Java 1 and in the software design development 1, and you were probably using the system.in and system.out to be able to perform those tasks. So let's talk a little bit about the built-in streams that are alias for us, that are pre-constructed and part of the default system streams. So Java represents a keyboard by a field called in, right? It's got that inside of the system class. The system.in, so that's a field, represents a standard input device, and by default, it's the keyboard. And so the system class is found in the java.lang package. As you might recall, that's where string is. That's where all of our reference primitive data types are, like integer with a capital I, double with a capital D. So whenever you have anything in the java.lang package, you don't have to import it manually. It's automatically imported into your source code. So system contains three fields that represent some type of stream. You have the system.in. This is the field that represents an input stream object, which is a standard input device known as the keyboard by default. You have a system.out. This field represents a print stream object. Again, we'll talk more about these in greater detail later on, but this is just giving you an idea of what you've actually been utilizing up until this point. So the system.out is a print stream object, which represents a standard output device. And again, by default, it is effectively your monitor. So it's used to be able to display messages to the console. And then there's also a system.er, which is also represented by a print stream object, which is defaults also to your monitor. And effectively, just like you were doing system.out.print, you could have at the same time that did system.er.print. So you could use either of those to effectively send data to the monitor to print it out. Typically, the distinction between system.out and system.er is that you'd use system.out to print messages that are intended to be displayed to the end user, and you'd send to system.er messages that are intended to convey errors or exceptions or any kind of logging information for situations that are not intended for the end user. It's something that had occurred that went wrong with your application. And usually on a well-crafted application, you'll try to log that information so that you can analyze it later and try to determine if there was some exceptional behavior, what caused it. Okay, I kind of want to just go through the final portions where we discuss what is the basic process on how we read data from a source into a Java program. And this is a notional, I'm going to go through the notional steps before we get into any implementation details. So notionally, to read data from a data source into a Java app, we do the following steps. One, we identify what the data source is. And that could be like a multitude of things, right? It could be the keyboard, it could be a file, it could be an array, it could be a string, it could be a network connection. There's something that has data that we want to import into our application. The next thing we would do is we would create an input stream by using the data source that we identified. The third step in this process is we would then read the data from that input stream that we've instantiated, that we've constructed around the data source. And basically, when we read a data, we usually do that in a loop. So long as we keep receiving data, we'll keep reading it in. And then fourth, finally, we're going to close that input stream once we're done reading from it. And so just know from Java 7 and onwards, you could use a try with resources block that will close the input stream automatically when it's done. And the steps by which we would write data to a destination from the Java program is relatively similar to the way we would read it. So the first thing we would do is we would identify what our destination is going to be for our data, where we want to write it. And that destination could be any number of things. It could be a monitor, it could be a file, it could be an array, an in-memory array, it could be a string, it could be a network connection. Once you have identified what the destination is going to be, the second step is we would create an output stream that we would use to go ahead and send to that data sink, that data destination. And then the third step would actually write the data into our output stream. And then the fourth and final thing is to close the output stream once we're done writing that data. And again, from Java 7 onwards, we can use a try with resources block to close that output stream automatically. And so the basic idea here is what streams allow us to do is be absolutely ignorant about what is sending the data or what the sink is, right? We can abstract away the minutia, the details about what our actual data source is, or what our actual data sink is, and we can just focus on receiving data in a stream and sending data in a stream. So it allows us to really abstract the concept of input and output, and that's one of the most powerful things about what streams allow us to do inside of Java. Excellent. So that's just a quick explanation about what streams are at a very basic fundamental level. So does anyone have any questions, at least about like this conceptual concept of streams and how Java is making use of that, at least in a theoretical space, for being able to move data into your application and move it back out to some other source or some other target? So a question is, so a data sink is any destination for an output stream. Yep. And one of the beautiful things about output streams is it could be a file, it could be a network connection, it could be an array, it could be a string, it could be anything. It could be the monitor, it can be a printer. And the process by which we write our data out of our Java application remains the same. So yeah, the data sink can be anything. And then the way that we write out to that data sink will be uniformly similar. But it might just depend on which of the concrete classes we're going to select, whether it's a file or whether it's to the console, for instance, on how we're going to do that. But the way Java manages all that is pretty similar, because everything is essentially either implementing the output stream. Just like in order to get things in, all of these different concrete classes implement the input stream. Yeah. So a data sink is any destination for an output stream. Is there any other questions?